Good morning, grade 12 teachers. Good morning, grade 12 learners as well. My name is Mohapi, the Mathematics Subject Advisor for Motao District. So today we are going to outline or to give tips as to what must be expected in Mathematics Paper 1. In short, we are going to have examination preparation for Mathematics Paper 1. Maths Paper 1 will be written this coming Friday. Without any waste of time, let's get into the matter. Like I said, my name is Mohapi. We are going to discuss exam prep for Maths Paper 1. This paper 1 will be written this coming Friday, on the 25th June 2021. It's written out of 150 marks and the time is 3 hours. Learners are expected to start writing at 9 o'clock in the morning until 12 o'clock. And this paper, they are going to write a provincial paper. It's not a national paper. It's a provincial paper set by the province. Maybe I should emphasize this. This exam is an informal task. Informal as it is, it's important for teachers and learners to take it seriously, because for reporting purposes, for term 2 reports, this June exam is going to carry 50% of the marks. For June reporting, 50% of the marks are going to come from this June exam. And remember, learners are going to use the very same reports to apply for admissions in the tertiary institutions. So it's critical, it's very much important that learners treat this exam seriously, as even though it is informal. Teachers must make time to thoroughly prepare learners. They must not just regard it as an informal task. It's informal in the sense that it's not going to contribute towards school-based assessment of the learner, the SBA of the learner. This June exam is not going to contribute towards SBA. That's why we say it is informal. However, it is important because, like I indicated a few minutes ago, that learners, this June exam is going to contribute 50% of the June examination mark. And learners are going to use those term 2 reports to apply at the tertiary institutions. They are going to use those results to apply for admissions at the tertiary institutions. Let's carry on. Remember, a maths paper, we have 4 cognitive levels. So this paper will be distributed according to the 4 cognitive levels. That is the level of difficulty. 20% of the paper, 20% of 150 will give you 30 marks. It's about 30 marks. It's just a recall. The easy, straightforward questions. I always say it's difficult to fail mathematics, because already knowledge type of questions, they contribute 30 marks. And remember, for a learner to pass, the learner needs 45 marks, which is 30%. So already the knowledge is 30 marks. You just recall, you identify a formula, and then you substitute. These are the the easiest questions of them all. And they carry about 30 marks, which is 20% of the paper. Thank you. That was the first cognitive level, which is 20%, which is knowledge. The second cognitive level is the routine procedures, which must carry around 50 to 53 marks. It's 35% of the paper. So between routine procedures and knowledge, already we have 35 plus 20, which will give you 55% of the paper. And 55, basically, it means you are at level 4 now. 55%, the learners got level 4. That's why I'm saying, if learners can prepare thoroughly, if teachers can assist learners properly, then learners must do well in this exam. Because 20% is knowledge questions, 35% is routine procedures. And it's 55. Routine procedures refers to proofs, derivation of formulae, you perform well-known things that you always do in class. Determine for example, determine the nth type of a quadratic pattern. Solve for x, quadratic formula. These are the easy questions. You can be, what can be expected, can be a derivation from the given information may be involved in this cognitive level. Generally, similar, these are the questions, the learners, by routine procedures, we are referring to questions that are similar to those learners that encounter in the classroom situation. Every day in a classroom, homework, classwork, these are the type of questions that learners should expect in the paper. Now, the next level, which is the third level, cognitive level 3, is what we call the complex procedure. Now it's starting to become difficult now. Now we have 30% of the paper being complex procedure. By complex procedure, we are referring to problems that involves complex calculations, high order reasoning and thinking. These are challenging questions. They demand the learner to concentrate and apply skills properly. There is often not an obvious route to the solution. Problems need to be based on a real world context and so forth as this cognitive level is explained. They require conceptual understanding. Learners are expected to solve problems by integrating different topics. This is cognitive level 3, challenging, mainly meant for those higher, so that they must also feel that now they are writing the mathematics. And it's about 45 marks. And the last cognitive level will be problem solving, which carries 15% of the paper. 15% of 150 marks is equal to 22 to 23 marks. These are non-routine problems. They are not necessarily difficult. Learners are not used to them. Hence, they say problems are mainly unfamiliar, high-order reasoning, and processes are involved. They might require the ability to break the problem down into its constituent. Because a question can be asked 7 marks. Down. If it's a 7-mark question, it means the learner, for the learner to answer that question, the learner must break it down to the constituent parts. Interpreting and extrapolating from solutions obtained by solving problems based in an unfamiliar context. I always advise them to say, these are questions, they only come up once. So the high order questions, problem solving, cognitive level 4. But they only carries about 15% of the paper. So if you add all the cognitive levels, they'll give you 100%. Remember, we have 20% for knowledge, 35% for routine procedure, 15% for complex procedure, and I said 30% for complex procedure and 15% for problem solving. But what needs to be emphasized is that for cognitive level 1 and level 2, namely knowledge and routine procedures, the two already constitute 55% of the paper. And learners, if the learners can get just 50% of the paper, then they have done very well. Let me go into the topics that paper 1 will be based on. Let's check the topics for mathematics paper 1. I've written them down here. The first topic is algebra, 25 marks. And it's the very first question. Then algebra. The second topic in paper 1 is patterns, sequences, and series, which carries about 25 marks. You've got 6 topics for paper 1. It's algebra, patterns, sequences, and series. The third one, functions and inverses, carry about 35 marks. Very much important topic. 35 marks. The next topic, we have financial mathematics, which carries 15 marks. We've got differential calculus, which carries 35 marks. And lastly, probability, which carries 15 marks. These are the topics for mathematics paper 1. However, especially for cognitive level 3 and level 4 questions, integration of concepts can still happen. Learners must not be surprised if in patterns, sequences, and series they come across trig ratios. It's integration of maths concepts. One of the previous years, in application of differential calculus, there was a question that requires the proportionality theorem, integration. So even though these are the main topics for paper 1, learners must still expect, the integration of concepts from paper 2. These are the 6 topics, and you add all the marks, they will give you exactly 150 marks. So this paper will be written this coming Friday. Grade 12 learners, you need to look at it. Remember algebra, we expect every learner to perform well. Pattern, sequence, and series, every learner to perform. Functions, mainly functions, remember they are grade 11 topics. For grade 12, you only include the inverses. And then we have financial mathematics for 15 marks. Financial maths, maybe I need to emphasize that financial maths will only be limited to grade 10 concepts. Let me repeat that one. Financial mathematics, that 15 marks, is strictly grade 10 concepts, because last year, due to COVID, schools were not normal, learners were not attending. As a result, teachers could not teach learners financial mathematics for grade 11. And for this term, financial maths and probability are scheduled for term 3. That's why we say in June exams, these are the topics that will be examined, but financial mathematics will be strictly limited to grade 10 concepts, as well as probability. Probability will also be limited to grade 10 concepts. I will go into details about each topic, but the main focus for today will be patterns, sequence, and series, functions and inverses, and differential calculus, for the simple reasons that those topics, they carry lots and lots of marks. So grade 12 learners, this is what we'll be writing about on Friday. Algebra, patterns, sequence, and series, functions and inverses, financial maths, grade 10 only, differential calculus, probability, grade 10 only. Let me go back to the presentation again then. Let me carry on and try to explain further what to expect in this June exam. Here are the 6 topics that I've talked about, and I've already indicated they are waiting. Here they are: algebra, patterns, sequences and series, functions, financial maths, calculus, and probability, and their weightings. There they are. Thank you. Take note, grade 12 learners. A question paper will have a cover page. Once the next page after the cover page will be instruction and information sheet. It's important for learners to read those instructions and informations, because they must adhere to them as they write the paper. Failure to adhere to the instructions will lead to learners being penalized. So it's important for learners to obey the instructions and adhere to the information provided in the information sheet. The last page of the question paper will then be the formula sheet, the formula sheet. Formula sheet is a sheet that contains formulae that learners must use or can use to solve some of the problems in the question paper. Let me start with algebra then. Remember, I said algebra carries 25 marks. What type of questions are learners are supposed to expect here? Solve quadratic equations. Basically, quadratic equations, we started with quadratic equations earlier, some few years back, while learners this grade 12 learners were still in grade 10, 2 years back. So carried on with the quadratic equations in grade 11. Even in grade 12, they still have to solve quadratic equations. The very first question, straightforward factorization. Doesn't require much. Just remember to write the equation in the standard form, and then you factorize. That's why it's right. Put it in the standard form. Write the equation in the standard form, so that the one side must be equal to 0, and then you start factorizing. Using quadratic formula. The second question is using quadratic formula. This is the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Know how to identify the value of a, the value of b, and the value of c, and then you substitute them. And more often, the question will come as solve for x, then they give you the equation. Then more often they will indicate to you, round off and give your answer correct to 2 decimal places. This is problems under algebra. Almost every question paper have these questions. Hence, it's important that for learners to prepare thoroughly for this June exam, they can use previous June exam papers, they can use previous SC and NSC question papers, September trial exam papers. They can use any resource. They do have these questions. Teachers, let's remember to remind our learners on how to solve equations that involve sets. How to solve equations that involve sets. Make sure that when you eliminate a set, before a set can be eliminated, then we must first isolate the set. Isolate means on the left-hand side we have a set. All these other terms will then be transposed to the right-hand side. Then you square both sides. Remember, after squaring both sides, you factorize, solve for x. After solving x, you need to verify, because it's a quadratic, because it's a quadratic, 2 values of x will be there. So more often, one of them will not be applicable. So you need to be able to take those values, test them in the original equations, and check which value satisfies the equation. The one that does not satisfy the equation, reject it by writing not applicable or invalid and so on. This is an area again where exponential equations can be tested. We talked of equations involving sets. Now we're saying equations, exponential equations. Exponential equation is an equation whereby the exponent is the unknown. That's an exponential equation. 2 exponent, 2x. You see, exponent is 2x. Now it becomes an exponential equation. Exponential equation is an equation where the variable is an exponent, or the variable is an index. Ensure that the bases are the same. Once you have the bases that are the same, equate the exponents. You must have dealt with a variety of problems or variety of equations, of exponential equations from grade 11. So it's just a revision of that. Please, grade 12 learners, revise properly. Once you have done the revision, you will see you'll do well in this June exam. And like I indicated earlier, this June exam is very much important, especially for admissions, because you are going to apply to use those results to apply for admissions at the tertiary institutions. Simultaneous equations. More often, one equation is linear, the other one is quadratic. One equation is linear, the other one is quadratic. So you go to the linear equations, you make one unknown the subject of the formula. Learners are always advised to show understanding, because in some instances, questions can be asked differently. I know even in the previous past June exam paper, that was written this year, there was a question that requires learners to solve x and y. Just one equations, which requires a little bit of understanding, a little bit of interpretation. So we still have to mark that and see if the learners did well in that questions or not. But learners, please expect simultaneous equations whereby you solve 2 unknowns at the same time. More often, it's x and y. So this is basically the algebra that we can expect 25 marks. Of course, simplification of exponential expressions can expect. Simplifications of expressions that involve sets can be expected. I'm here today to say grade 2, grade 12 learners, this is what you should expect in this coming June exam. So, in algebra, expect this that you see on the screen. Whatever you see on the screen, definitely, come Friday, you will be writing on those concepts. How do you solve quadratic inequality? Because part of algebra is quadratic inequality. I've hinted at some few steps that must be followed. Write the equation in the standard form, factorize, write down the critical values, draw a number line to show understanding, and then you make a conclusion from the number line. Greater than, less than, you, from that number line, you will then be able to make a correct conclusion. This is just a suggestion. Number line is not the only method used to solve quadratic inequality. Some schools or some teachers would prefer the quadratic, the parabola, the graph. But I believe more teachers, most of our teachers, they now use the number line to solve quadratic inequality, which is part of algebra. Nature of roots. It's not much. About 3, 4, 5 marks at most, part of algebra. This question can also be tested under functions, or it can still remain a question under algebra. Nature of roots will be incorporated with the solution of quadratic equations and functions. Type of questions, you investigate the nature of the roots, give the nature of the roots, confirmation of the nature of the roots. Please revise grade 11 concept, because this is basically all about the work that you did while you were in grade 11. So from time to time, it's important to revise, because 50 to 55% of the paper comes from grade 11. Just a brief reminder about nature of roots, discriminant, which is a factor that will inform you whether a discriminant is a factor that will inform you about the nature of roots of the quadratic equation. Nature of roots, for our case here, to describe the nature of roots, what do we mean when we say we've got two real roots? It means the graph will have two x-intercepts. See, two x-intercepts. Now here only have one x-intercept. There's only one root. This graph does not cut y-intercept. Therefore, we say the roots are non-real or imaginary. But the most commonly used term is non-real. If A is positive, the graph will face upwards. If A is negative, the graph will then face downwards. You see the three ones, these ones. 1, 2, 3. This graph, they are facing downwards, meaning the value of A is negative. Just a continuation of what we've discussed earlier about the nature of roots. Simultaneous equations, because it's an easy questions, learners can easily pick up marks. So we then said, let me try and give these learners a hint on how to solve quadratic equations, simultaneous equations. For learners to be able to solve simultaneous equations, one equation will be linear, the other one is non-linear. More often it's quadratic. From the linear one, make one unknown the subject of the formula. Bullet number 2, the linear one may be given in exponential form. It has happened in one of the previous years, whereby learners were given equation in exponential form. So if it's in exponential form, don't panic. Remember the rule when you solve exponential equations. Ensure that the bases are the same. Once the bases are the same, you then equate the indices. You then equate the exponents. Then you can be able to come up with the first equation. Quadratic formula may be used in case you come across equation that does not have factors, or you come across equations and you are struggling with factors. You just use quadratic formula. The only disadvantage of a quadratic formula is that it is time consuming as compared to factorization. But just to make sure, because we want marks, we use quadratic formula. It is there in the formula sheet. Copy it into the question paper, substitute properly, punch in the values in the calculator, then you have the answers. That's it about simultaneous equations, exponents and sets. For learners to get marks here, learners must understand, they must have a thorough understanding of exponential laws and how those laws must be applied. We also have the type of questions under exponents and says, can have equations or can simplify expressions. Those are the two possibilities. It's either you solve exponential equations or you simplify exponential expressions. Thank you. Now here is the topic: patterns, sequences, and series. Patterns, sequences, and series. 25 marks. I will treat this one separately. It's important to know that knowledge of linear patterns can be tested in the context of quadratic patterns. What is a quadratic pattern? A quadratic pattern is a pattern in which the second difference is common. Before you can determine the second difference, you first need to calculate the first difference. That's why the statement reads, knowledge of linear pattern. What is a linear pattern? Remember, you've got a quadratic pattern. The first difference constitutes linear pattern. The first difference is basically a linear pattern. Hence, just to make learners aware, that linear pattern can be incorporated. A clear distinction must be made between arithmetic and geometric sequence. Remember, arithmetic, there is a common difference denoted by the letter D. Geometric, there is a constant ratio denoted by the letter R. So, even formulae for summing arithmetic and geometric, they differ. Even the nth term of arithmetic and geometric, they differ. Just revise, make sure that you do a proper revision, and then you'll be able to answer these questions. I will take you through some of the possible questions that one can expect under patterns, sequences, and series. Sigma notation under sequences and series. Sigma is nothing else but sum. Once you see sigma notation, then you know now we are going to calculate sum. We are going to add. It's either it's an arithmetic or geometric, then you must be able to know which formula to use. Questions relating to convergent series. For a series to converge, R must be greater than -1 but less than 1. Meaning the value of R must be between -1 and 1. That is the most critical concept that grade 12 learners must know about a convergent series. And once a series is convergent, then learners can be able to calculate sum to infinity of that series. Sum to infinity only exists for a series that is convergent. Once the series is divergent, it's impossible to determine its sum. Because if you say sum up to infinity of how many terms, if it's the divergent series, it becomes impossible. Let me take you through some of the concepts on patterns, sequences, and series. Some of the possible questions on this topic. Look at this one. The first 4 terms of quadratic patterns are, here they are, 15, 29, 41, and 51. Write down the value of the 5th term. If you know a quadratic pattern, it becomes easy because all you need to do, determine the first difference. Once you have the first difference, it becomes easy for you to write down the nth term and so forth. Hence, it's even 1 mark. It's a knowledge type of a question. 1.1.2, determine the expression for the nth term of the pattern in the form Tn is equals to an squared plus bn plus c for 4 marks. Daily routine. There is no way that a teacher can be in class with learners, teach them about the quadratic pattern, and then the teacher cannot show them how to determine the nth term of the quadratic pattern. Every CAPS compliant textbook has got the notes and the examples on how to determine the nth term of a quadratic pattern. That's why we say this is just a daily, a routine procedure. Every learner must be able to do. Determine the value of T27. Remember, you have Tn. If we say T27, You then substitute n by 27 in the nth term. You see, in this nth term, this is the nth term. You substitute n by 27. Take your calculator, determine the value. That's it. As I'm going to continue with this. Sometimes they can give you the Tn. They say which term of the sequence is equal to whatever value. Then in that case, you know that you need to determine the value of n. Equate the quadratic pattern to that nth term, and then determine the value of n. Some more examples. Look at this one. Given a geometric series, 36 minus 89, it's a geometric sequence. Determine the value of r. Because it's r geometric, you know r is t2 divided by t1, minus 18 divided by 6 is half. Or we can say t3 divided by t4, 9 divided by negative 18 is negative a half. Calculate the value of r, common ratio, calculate the n. If Tn is equal to that, you just have to equate. Calculate the sum to infinity because r will be less than 1, but greater than negative 1. Then you can determine the sum to infinity. High order, the last one, 1.2.4, is a high order type of questions. You need to determine T1, T2, the odds. Numerators are the odd numbers, denominators the even numbers. So you go to a series, take the odds, take the evens, and then you determine their sum. And then you divide. This is what to expect. I'm just trying to highlight it to Gr12 learners so that they shouldn't be surprised on Friday when they see a question paper. They must see it as a familiar, something they are used to. The first three terms of arithmetic sequence are this: 2p plus 3, p plus 6, p minus 2. Very, very important. Show that p is equal to 11. In an arithmetic sequence, learners must know that T2 minus T1 is equal to T3 minus T2. Let me repeat that. In an arithmetic sequence, T3 minus T2 is equal to T2 minus T1. You equate, you form an equation. And when you substitute the values, we use brackets. If you miss out on brackets, you're going to get the wrong solution. Please, Gr12, you need to listen attentively. Please, let's avoid, losing marks unnecessarily. This is knowledge type of questions. You just say, you just need to recall. This is arithmetic. Therefore, T2 minus T1 is equal to T3 minus T2. You substitute inside the brackets. The first term is 2p plus 3, the second term is p plus 6, and the third term is p minus 2. Calculate the smallest of n for which Tn less than minus 55. It's very much similar to the one that we've shown earlier. You are given Tn. So you need to determine the nth term. And that nth term will be minus 55, and then you work it out. The last one will be on sigma. This is basically more or less what learners must expect under sequences and series. Given the quadratic pattern, look at this one here, given a quadratic pattern. Write down the next two terms of the pattern. Determine the formula for the nth term of the pattern. Which term of the pattern will have a value of that? Now, it means this becomes Tn. You read it slowly. Which term of the pattern? N denotes the position of a term in a pattern. If we talk of Tn, it's the nth term. If we talk of T5, it's a term that occupies the fifth position in the pattern. Or if we talk of T8, it's the term that occupies the eighth position in the pattern. So now, which term of the pattern will have a value of 1765? You equate that to Tn. Once the answer you obtain in 3.1.2, you equate it to 1765. Now that you have that equation, you then write the equation in the standard form and solve. If you struggle with vectors, just use quadratic formula. Interesting. But these are the possible questions. These are the questions that learners can expect under sequences and series. Even the word problems, here they are. Even the word problems can be examined. I'm sorry. These are the word problems. Temba is planning a bicycle trip from Cape Town to Pretoria. The total distance of the trip is 1,500 kilometers. The moment they say total distance of the trip is 1,500 kilometers, it means total. What do you understand by total, grade 12 learners? What do you understand by total? Total means you add the sum. Sum is 1,500 kilometers. He plans to travel 100 kilometers for the first day. That is A. A is the first term. First day, 100 kilometers. For every following day, he plans to cover 94% of the distance he covered on the previous day. R is 94%, 0.94. You have a geometric. A is 100, sum 1,500, R is 0.94. You can work it out. Answer all the questions. So expect these are the word problems, especially under sequences and series. What distance will he cover on the third day after starting? It means you need T3. You got the value of A, you've got R. It's easy to work out T3. You know the formula for T3, it's AR. Formula for T3 is basically AR. First term is 100, R is 0.94. Easy to work out. So the answer for 4.1, what distance will he cover in the third day? Formula for T3 is AR squared. Yes, AR squared. Then you write AR squared. You know A is 100 kilometers, R is 0.94. Punch in the calculator, you have the answer. Whether you give answer in decimal or in fractional form or whatever form, it's fine. How many days after starting this trip will Temba pass the halfway? You just read, will Temba pass halfway? Remember, total is 1,500, given the statement. Halfway will then be 750. How many days? Then you start working on n. Now you have sum, work out the value of n. You have A, you have R. I'm just trying to highlight the approach. And I'm saying these are the questions that learners should expect in the June exam tomorrow. Check this question 5. The geometric series, x minus 2 plus x squared minus 4 plus, there it is. Determine the values of x for which the series converges. The first term is x minus 2. The second term you factorize. It will be x minus 2, x plus 2. Third term you factorize. You'll see there is this common factor that you keep on adding. X plus 2, x plus 2, x plus 2. So it's easy. For what values of x for which the series will converge? T3 divided by T2 is equal to. For a series to converge, the golden rule, for a series to converge, R must be greater than -1 and less than 1. That's where we start. Now you work out the value of R. R is basically T2 divided by T1. Obviously, you work it out here. R will be x plus 2 because it will be T2 is x squared minus 4, T1 is x minus 2. Remember, x squared minus 4, you factorize it, it will be x minus 2, x plus 2. So it's easy to work out the value of R. And remember, for a series to converge, R must be greater than -1 but less than 1. Then you substitute R by x plus 2, work it out, done. 5.2, if x is equal to -3/2, calculate the sum to infinity of the given series. Sum to infinity, you know the sum to infinity. Grade 11, 12 learners, I have lots and lots of examples here. I cannot take you through all the examples because of time. I cannot take you through all the examples because of time. But this is what you should expect tomorrow not tomorrow. This is what you should expect on Friday when you sit for June exam paper. I've talked about algebra. I've talked about sequences and series. Let's go to the next topic then. Let me go back to my presentation. This was sequences and series. The first topic you said is algebra. The first topic is algebra. The second one is patterns, sequences, series. Let's check the third topic. Functions and graphs. Functions and inverses. 35 marks. 35 marks. This is what learners are supposed to expect. The domain, range, axisymmetry, asymptotes, clearly understood. This is what learners can expect. Range, especially if you talk of range, especially in a quadratic function. Axisymmetry, especially quadratic. Asymptotes, hyperbola. Even exponential has got only horizontal asymptote, but hyperbola has got 2 asymptotes. Transformation, reflection over the x-axis, reflection over the y-axis, and so forth. Translation, you shifting to the right, f at x plus is 30 degrees to the left, or shifting to the right and shifting to the left. F at x plus a, this one is upward when the graph shifts upwards. Sorry for that. Here it is. Upward. This one here, left, right. Learners must be able to sketch graphs. Let me be specific. Hyperbola, quadratic. Learners, there's no way that learners must go to the exam without knowing how to sketch those. Sketching and interpretation of graphs must be treated separately. Let me take you through some examples on functions and inverses. This is a quadratic function. Just to take you through this quadratic function, y is equal to ax squared plus bx plus c, or y is equal to a into x plus p plus q, or a into x plus p all squared plus q. To sketch the graph, we want x-intercept or y-intercept and the turning point. And if it is given in this form, in this format, the turning point will then be minus p and q. If it is given in this format, turning point minus b over 2a, you get the x value. Once you get the x value, go x is equal to minus b over 2a. After getting the x value, you substitute that x value into the original equation. This is an example of what I'm referring to. You can be given this. Write down the coordinates of the intercept of the axis. Intercepts of if the axis refers to x-intercept and y-intercept. Domain and range, turning point. If you really want to do well in mathematics Gr12 learners, make sure that you know how to calculate the x-intercept, the y-intercept, and the turning point of a quadratic function. And once after turning point, use that turning point to determine the range. Any question relating to the range, then you'll have to use that value of y for the turning point. This is more or less of what to expect under functions. Yes, now in this case, the parabola is drawn. Your task will then be to determine the equation of the parabola. Check what is given. Because you are given the turning point, the formula we use will be y is equal to a into x minus p all squared plus q. That is the formula we will use to determine the equation of this graph. Grade 12 learners, what to expect? It's either you draw a quadratic function, but if it's drawn, you will be expected to determine its equation. There are the possible questions then. The range, coordinates of R and S. R and S are the x-intercept. So to work out the coordinates of R and S, you just equate the quadratic equation, the quadratic function to 0. I'm just trying to highlight. Another example, there it is. Hyperbolic function. To sketch a hyperbola, we need 3 things. Intercept with the axis, that is x-intercept and y-intercept. Horizontal asymptote, y squared q, and the vertical asymptotes. This information is key. That information is key. That's when we talk about hyperbola, hyperbolic function. The asymptotes, like write down the equations of the asymptotes. If the question wants you to write an equation, equation has got equality sign. Equation of asymptote is x is equals to 1. X is equals to 1. That is the equation for vertical asymptote. Y is equals to 3. That will be the equation for horizontal asymptote. Expect this type of questions, grade 12 learners. Definitely. And again, under this, the very same graph, hyperbola. Let me make an example. Check this example. K at x is equals to 1 over x minus 1 plus 3. Write down the equation of the asymptote. I've talked about that one. Determine the intercept with the axis of k. Intercept with the axis refers to x-intercept and y-intercept. If we talk of the intercept with the axis, we are referring to x-intercept and y-intercept. Sketch the graph. Write down the equation of the line of symmetry of k, where m is less than 0. Remember, the line of symmetry is sometimes referred to axis of symmetry. This graph is y is equal to plus or minus x plus c. Let me write it down. Axis of symmetry, y is equal to plus or minus x plus c. All you have to do, check if gradient is greater than 0, it's positive gradient, so y is equal to x plus c. If gradient is less than 0, like it is the situation right now, minus x plus c. Now that how do you work out the value of c? Because if you have the gradient is negative, it will be minus 1. If it's greater than 0, it will be plus 1. So in this case, it's less than 0, so it's minus 1. So the equation becomes y is equal to minus x plus c. How do you work out the value of c? Use asymptotes. How do you work out the value of c? Use asymptote. X is 1, y is 3. That's how we use the asymptotes to solve the equation. Write down the domain of k. Remember, domain x will always be an element of real numbers, but x will not be equal to vertical asymptote. For range we say y is an element of real numbers, y is not equals to horizontal asymptote. So that must be stated clearly. These are more or less the type of functions, questions on functions that we can expect. Now, in this case, the graph is drawn. Your task as a learner is to determine the equation of the hyperbola. Already, you can tell the asymptotes here. This vertical line is asymptote, and x is 2. So x is equal to 2, meaning we have x minus 2. Denominator here, you have x minus 2. So that when you solve for x, you equate the denominator to 0, x should be equal to 2. Meaning p is already equal to 2. So the denominator for x minus 2, check y. Q is 6. So the equation is a over x minus 2 plus 6. How will you determine the value of a? Then we use this point, x is half, y is 0, to determine the value of a. Let me say it again. How do we determine the equation? I'll be slow, hoping that everyone will understand. From the asymptotes, one could tell that p is equal to 2. So the equation is a over x minus 2 plus 6. The only variable now becomes a. How do we determine the value of a? Now that we've got g at x equals to a over x minus 2 plus 6. Use this point as x is equal to 5 over 2 and y is equal to 0. Substitute x by 5 over 2 and substitute y by 0. Then you can work out the value of a. Grade 12 learners, we must learn that let's try to use every information that they give to us. Let's try to use every information that is given to us, because that information will help you to solve questions on that diagram. These are the functions, more or less, what we should expect. This is also very much similar to the previous one, because you still have a over x minus p plus q. You still have that point. and T is a point on F. Here is a point on F. Determine the values of A, P, Q. It's basically determine the equation. What do? Asymptotes. Asymptotes is minus x is 4, y is minus 2. We've got 5 and 3 as a point on the Cartesian plane. So use that point to determine the value of A. Very much similar to the previous one. Hyperbolic function. Hyperbolic. No, not hyperbolic, exponential graph. More often, here it is. This graph, it only has got horizontal asymptote. And the horizontal asymptote in this case here, it's y is equals to 9. So you go to 9, you draw a line. Because of this negative, it will be going downwards. Write down the equation of the asymptote of r. Y is equals to 9. Determine the x and the y-intercept. Then you can sketch the graph. Grade 12 learners, make sure that you are able to sketch graphs. And if this graph is sketched, be able to determine the equation of that graph. This is more or less of what to expect. Here we have a situation whereby I've got two functions drawn on the same set of x's. In this case, you've got the quadratic, and we also have a linear. How would you calculate the coordinates of A and B? The first question, calculate the coordinates of A and B. Here is point A, here is point B, the x-intercept of the quadratic function. So you go to the quadratic function, equate f at x to 0, solve for x. I'm showing grade 12 learners these questions because I know come Friday they are going to come across this. So they must see this as something familiar. Prepare yourself on this type of questions so you'll see on Friday you'll be able to handle them all. Find the length of OC and so on and so on. Thank you. I've talked about functions. I've talked about pattern sequence and series. I've talked about algebra. I'm left with this next 3 topics, namely financial mathematics, probability, and calculus. Fine, let's go back to our PowerPoint presentation. Here we are, we're talking about functions there, and we've talked about the functions. So the next topics after functions will be quadratic function sketching. Let's check, how do we sketch? This is what I've indicated earlier. The value of A determines the shape. If A is positive, face upwards. If A is negative, faces downwards. Find x and y-intercept. For y-intercept, x is 0. For x-intercept, y is 0. Turning point, determine my x equals to minus b over 2a. We've got the x value. Then that x value substitute in the original equation to determine the corresponding value of y. Equations can be given in 2 different forms. Y equals ax plus bx plus c, and y equals a into x plus p plus q. Teachers, it is your responsibility to ensure that you expose your learners to questions where the equation is in this format, ax plus bx plus c, and the questions where the equation is given in the form a into x plus p plus q all squared. Determine the equation. Sometimes learners can be expected to determine the equation of the parabola. How do we determine the equation of the parabola? If the x-intercepts are known, this is the formula we use. Look, a into x minus x1, x minus x2. x1 and x2 represent the x-intercepts. If the turning point is given, you use the formula y is equals to a into x plus p plus q all squared. Here it is. Just look at what is given. Utilize the given information. To make it easy, if the equation is in this format, ax squared plus bx plus c, this is the formula we use to determine the equation. But if the turning point is given, then you use the formula y is equals to a into x plus p all squared. Hyperbola. I've already talked about the hyperbola sketching, x-intercept, y-intercept, asymptotes. know those things, how to determine those things. Y is equals to a into x plus p all squared. First asymptotes, and you'll find another point. You'll be given another point. You just have to substitute, like I showed you in the examples that I did previously. Here is an exponential graph. Go through it, prepare, make sure that the three functions that I've emphasized today, it's exponential graph, quadratic, even hyperbolic, hyperbola. Those are the three main functions that you must know. If you're not going to be asked to determine the equations, you are going to be asked to draw one of them. Deductions from the graphs. Mainly, this is the section of the work that is meant for high performers. Deductions from the graphs. It's basically meant for high performers. And there are some notes relating to the deductions. These notes will help you as a learner to be able to make deductions. Inverse functions. Remember, in the inverses, x swaps with y. The x value becomes the y value and y becomes x, and then make y the subject of the formula. You can see it's highlighted in yellow color there. The inverse of a function is the symmetry of the graph about the line y is equals to x. Very much important. Quadratic function, the inverse of a quadratic function. Remember the quadratic function, look at this one, it's f at x. It's facing upwards. A must be positive. The inverse is this one. This is the inverse. Grade 12 learners, be able to sketch the inverse of a quadratic, by heart for that matter. If they want to a point on the graph, just indicate any point, x is 1. So if x equals 1, you take that 1, substitute in the original equation to determine the corresponding value of y. And basically, inverse functions is about swapping. X becomes y, y becomes x. Simple as that. The exponential inverse, very much important, because the exponential inverse, the inverse of the exponential graph is the log. So remember the definition of logarithms. If x is equal to a exponent y, then y is equal to log x base a. That is the definition. We have graphs here. If a is greater than 1, it's an increasing function, and below here is the inverse thereof. Increasing, increasing. This one is the inverse, the log graph, because the inverse of exponential is log. And these are the conditions for the graphs to be increasing or decreasing. Let us take note. You must be able to sketch graphs. You must be able to determine the equations of functions, discuss and explain the characteristics of functions such as domain, range, axisymmetry, and so forth. Explain to the teacher between two functions. Explain the relationship between two functions. That's the interpretation, high order question. Explain the effects of the parameters, shifting to the right, shifting upwards. This is mainly more or less what learners must know on functions. I'm going to take 5 minutes break now. And when I come back from break, we'll be left with calculus, financial mathematics, and probability. We'll then discuss those 3 topics quickly, and then that will bring us to the end of the session for today. For now, grab some water and refresh your mind. Thank you. Welcome back, grade 12 learners. Welcome, work teachers. We still carry on busy with exam prep for mathematics paper 1, which will be written this coming Friday. We have already discussed algebra, patterns, sequences, and series, and functions. So we are left with the 3 topics: calculus, probability, and financial mathematics. Without any waste of time, let's carry on with differential calculus. As displayed on the screen, This topic, differential calculus, carries 35 marks, a lot of marks. What must learners know? First principle. The very first question on differential calculus, the very, very first question on calculus will be the first principle. Learners, and the formula for the first principle is in the information sheet, the formula sheet. F prime of x equals the limit as h approaches 0 of f at x plus h minus f at x all over h. Take note. I said today's presentation is all about preparing learners for paper 1 to be written on Friday. Learners must see familiar things, familiar questions. They must come across familiar questions. So that's why we have this exam prep, so that learners must not be shocked when they enter the exam room. And remember, these are the learners that have never sat for exam, basically. The last time they sat for exam, probably when they were in grade 10. Grade 11, due to COVID, there were no exams. This will be the first exam over a period of a year. So it's important for us to prepare them properly. They must not be panicked, they must not be shocked, they must just stay calm and relax at all times. Coming back to mathematics, immediately after the first principle, there'll be rules for differentiation. Then after rules for differentiation, gradient to the curve. Gradient is nothing else but the slope. How do we know the slope? But you differentiate. That first derivative is called the gradient. That first derivative is called the slope. F, how do we denote it? F prime of x, dy over dx, y prime. You know those notations. Those are notations we use for the gradient. Learners must not be confused. Once they see the letter slope or gradient, they know they just have to differentiate whatever function is given. Then they get the gradient. Cubic functions, that's where more marks are. Learners must be able to sketch a cubic function. Remember, to sketch a cubic function, we need three main things. X-intercept. To determine the x-intercept, we use because it's a cubic function, we use different methods. Make sure that you familiarize yourself with the method that you use. Whether it's table method, whether it's long method of division, any method that you use, make sure that you become familiar with. Prepare yourself on that methodology of determining the x-intercept. Because when you are asked to sketch a cubic function, you must first determine the x-intercept, and then the y-intercept, and then the stationary points. Stationary point is nothing else but a turning point. How do we determine the turning point? F prime of x must be equal to 0. You equate the derivative to 0. It's a cubic. The moment you differentiate, you get a quadratic, and that quadratic will then represent the gradient. And at the turning point, the gradient is 0. That's why we equate the derivative to 0. Then you work out the two x values. Once you've got the two x values, to determine a point, a turning point, you take those x values, substitute them in the original equation of a cubic. The x values that you obtained, substitute them in the original value of the cubic to determine the turning points. Take note of a point of inflection. How do we point of inflection? F double prime of x is equal to 0. Double the derivative, f double prime of x will then be equal to 0. Then you'll be able to determine the point of inflection. Familiarize yourself with the concept like area where the curve will be concave up. You know, for concave up, we say f double prime of x greater than 0. For concave down, f double prime of x less than 0. Familiarize yourself with those concepts. They are there in the previous papers. Get used to them so that you don't get shocked in the exam. Equation of a tangent to the curve. What is a tangent? It's a line that touches the curve. It's a line. Because it is a line, y minus y1 is equal to m into x minus x1. It's a formula that we use to determine the equation of a line. So a tangent is a line. We'll use that formula to determine the equation of a tangent. And you know, if we use that formula, y minus y1 is equals to m into x minus x1, if we use that formula, first get the gradient, then get x1 and y1, a point where the graph touches the curve. Lastly, on calculus, there'll be optimization, commonly known as application of calculus. And the optimization, we know that it's a very challenging. More often, high-order questions come from that question, optimization, or the application of calculus. All what is important is that to get maximum area, you determine the derivative of the area, and then equate the area to 0. If you are given a volume, for optimization, you differentiate the volume, dv over x, and then you equate the derivative to 0. I'm not sure what is it that we'll be talking about. Whatever that the question will be talking about, for you to optimize it, you determine its derivative and equate that derivative to 0. Then you can work out the x values and so forth. Let me take you through some questions on calculus. It's a very important topic. Determine f prime x from first principle if fx equals to 4x squared. I need to emphasize. This is a possible question, quadratic. If the equation is not quadratic, it can be a over x. It can be hyperbolic, a over x, 3 over x, 2 over x, 1 over x, whatever. It can be cubic, ax cubed. Can be 2x cubed, 3x squared, minus 4x squared, whatever. According to policy document for mathematics, first principle is limited to 4 concepts, namely quadratic, like the first question, 1.1, can be cubic, can be given 4x cubed. It can be hyperbolic, 4 over x, 3 over x, minus 2 over x, or it can be linear, 3x minus 4, or a constant, whilst f at x equals to 5, and so forth. Those are the questions under the first principle. And I'm telling you right now, the first question on calculus on Friday will be on the first principle. Teachers, my humble appeal, let's prepare the learners thoroughly. Let's do our best to prepare learners. Remember, COVID disrupted our plans. We could not cover the curriculum as expected. So learners are having those learning losses. So it is our responsibility as teachers to work hard and assist these learners to do well at the end of the year. Remember, the end of the year, paper will be standardized. All concepts will be examined, despite the disruptions by COVID and whatever shutdowns that happened. Despite all those, learners are going to write a standardized question paper. And like when I started, I said we have 4 cognitive levels. It's knowledge, routine procedure, complex procedure, and problem solving. And that paper that the learners are going to write, marks will be distributed accordingly. So we need to make sure that we prepare our learners properly. I've just indicated some of the possible questions. Check 1.2. It's about the application of rules. Some refer to as a power rule. Determine dx into x squared minus 2x minus 3 all over x plus 1. Very much important. Check the notation. It's easy to simplify because all you have to do, you factorize the numerator. It's x minus 3, x plus 1. So x plus 1 will cancel x plus 1. It's easy. But learners must take note of notation. The moment you differentiate, dx falls off. The moment you differentiate, dx falls off. But when you simplify, like with factorizing, cancelling, dx will still be there. Dx will disappear the moment you differentiate. Check 1.2.2. Determine f double prime of x if f at x is equal to the square root of x. You have a set. For you to be able to differentiate, the expression must be in exponential form. So you need to be able to convert a set to exponential form. So this one, square root of x is the same as x exponent half. learners must have a skill to convert from set to exponential. Because once the expression is given in set form, it's going to be difficult or impossible to determine the derivative. Hence, the learners must first change the format, the form of the expression, such that it can easily be differentiable. And that form means the expression must be given in exponential form. Check 5.2. Determine f prime of x prime at 2. It means for you to determine f prime of 2, simplify f at x, determine the derivative. After determining the derivative, and then determine f prime at 2. Let me repeat myself. Check 1.2.3. Obviously, we'll have to take out x squared as a common factor in the numerator. X squared as a common factor in the numerator. Then they will cancel. X squared will cancel x squared. Then it becomes easy to simplify. Now we have 2x minus x squared over 4 over 2. It becomes numerator, take out x squared as a common factor, then simplify. Determine dy over dx. Why am I showing you this? I'm trying to expose you to a variety of problems and a variety of notations. The first one was about dx 1.2.1, 1.2.2 f double prime of x, 1.2 f prime at 2, 1.2.4. Now we talk of dy over dx. I am not the examiner. I don't know what the notation or the notation in the paper is. But as a grade 12 learner, I'm advising you, be familiar with all these different notations, because you do not know which notation will be used. Determine dy over dx if y is equal to minus 6 over x exponent 7 plus 5 over x exponent 6 plus 4 over x exponent 5. You know, it's not in a differentiable form, but for you to do well, especially in the application of power rule, the power rule of differentiation, for you to do well, revise exponential laws. Revise exponential laws, so that questions like this, 1.2.4, you just have to recall the exponential law. It becomes minus 6x exponent negative 7 plus 5x exponent negative 6 minus 4x exponent negative 5. Now the question is in a differentiable form. You can differentiate. You can determine the derivative. And many others. I have many other different forms. But this is basically what to expect under calculus for first principle and for application of rules. Lots and lots of variety of problems. Just that time does not allow for me to take you through each and every one of them. But I'm telling you, these are the type of questions that you should expect for this coming Friday. Fine, let's talk about cubic functions. What type of questions? Check what is given. What is given will tell you which formula to use to determine the equation of a cubic function. And already they say the graph is minus x cubed. So the moment it's minus x cubed, the graph starts by decreasing. It goes down, it decreases. Turning point and then increases. Turning point and then decreases. So on. That's a cubic function. The graph of f equals minus x cubed plus ax squared plus bx plus is sketched below. The x-intercepts are indicated. How would you determine the equation of the value of a, b, and c? Y is equal to a into, because a is all, the coefficient of x cubed is negative 1, we'll write y is equal to minus 1 into x minus 1, x minus 2, x minus 4, because we are given the x-intercepts. Minus 1 into x minus 1, x minus 2, x minus 4, because we are given the x-intercepts. You'll be able to determine the equation of the cubic. The next question, calculate the x coordinate of A and B, the turning points. I did highlight it to say turning points. To determine the turning points, you equate the derivative to 0. First differentiate and then equate the derivative to 0. Check the other one. 11.2. Learners are expected to sketch that function. Use the fact that f at 2 equals 0 to write down one factor of, if f at 2 equals 0, x minus 2 is a factor. F at 2 equals 0. According to factor theorem, therefore x minus 2 is a factor. Write down, calculate the coordinates of the x-intercept. Because already you've got x minus 2 as a common factor, you factorize the cubic. You've got x minus 2 as a factor. Use law method to whatever method that we've been using, revise that method, ask your teacher to explain again, go through a series of activities on how to factorize a cubic, so that you should acquire a skill, and once you have the skill, it will be easy to factorize. Calculate the coordinates of the stationary points. These are the questions. Stationary points, x-intercepts. These are the key questions. Sketch the graph. These are the key questions under calculus. This one, you still have to determine the equation, but you are given the turning point. Take note, turning point is minus 1 and 1. It means you substitute x by -1, you substitute y by -1. At the same time, I said it's a point, minus 1 and 1. Substitute y by -1, substitute x by -1. You've got the first equation. To get the second equation, this is a turning point. Minus 1 and 1 is turning point. So if this is a turning point, we know at the turning point, derivative is equal to 0. You differentiate this, it will be 3x squared plus 2ax plus b. Now, derivative will be equal to 0 where x is equal to -1. Equate the derivative to 0 where x is equal to -1. Then you'll have the second equation. Then you solve the two equations simultaneously. Then you'll have the value of a and b. This is more or less what to expect under calculus. So many questions. I cannot take you through all the questions. I can't. But this is what to expect. I encourage us to use the previous papers to prepare themselves for this exam. Let me go to probability and financial mathematics. Calculus, I've tried to indicate what to expect. Let's go to the next topic. Finance, growth, and decay. Take note. Only grade 10 content will be tested. As you prepare for this June exam, only grade 10 content will be tested. Which content? Simple interest. The formula is there. A is equal to P into 1 plus I n. Compound interest. A is equal to P into 1 plus I exponent n. Those are the concepts that will be tested. Fluctuating foreign exchange can also be tested, but more or less, this is what to expect under financial mathematics. Remember, due to COVID, the paper will be limited to grade 10 concepts only, because learners were not taught grade 11. You, as a grade 12 learner now, you were not taught to financial maths last year because you were staying at home due to lockdown brought by, COVID issues and so forth. So that is financial mathematics, only 15 marks. Grade 10 concept, it is not much. Let's go to probability. 15 marks as well. Only grade 10 content will still be tested. What am I referring to? Venn diagrams, probability rule, probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. Remember, for mutually exclusive events, probability of A and B is equal to 0. Do not mind the last one, I think it's a mistake. But that is basically what to expect under probability. Only grade 10 concepts. For the same reason that due to COVID, learners were not taught these concepts previous year. And this will then bring me to the end of the presentation for today. And let me take this opportunity to wish you well in this coming June examinations. Please, COVID is there, it's real, it's killing people. Let's try by all means to be safe. Let's sanitize, let's wear masks, let's practice, let's adhere to the rules and regulations of COVID. Grade 12 learners, I wish you the best. Thank you very much.